Bonjour and welcome. This is Wahsa Distance Education Center's radio Zoom classes. And this is MBF3C, grade 11 college math, and I am Bronwyn Slate. Just to make sure everyone knows how to participate, if they want to, you can call into the Wahsa studio to ask questions at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or watch through the television on Bell Express View, channel 972. We have the Zoom link that you can participate through. It's available from me, your teacher, or through your DEC. I've turned on the subtitles, so if you are joining us through Zoom Live, you can turn them off if you'd like. You go down to more or where it says live transcript, depending on how your screen is, and then you can hide or show subtitles depending on what works best for you. A reminder that our radio Zoom schedule is on Monday through Thursday from 11 to 12. That's when our grade 11 math class is airing. And we are in week 1 of our 9-week class. What work is best you need to submit for marking? So not the support questions, the ones that are marked with a pencil. Those are not for marking. Those are the ones that you decide which ones and how many of them you're going to do. I'm reminding you that if you understand a concept, please feel free to skip them. Do the questions that you need to help. The answers are in the back, so check your work to make sure you're on the right track. If you notice that answers are not lining up with your work and you want to verify them, let me know and we can check them. I found answers in the back and also in some of the questions, so they happen. Key questions, the ones marked with a key, are the ones that I will be marking, so those are the ones you need to submit. Please do them all and show all of your work, all of your steps, all of your thinking, so I can give you credit for all of the knowledge that you have. If you only give me the answer and it is you've made a calculation error or a calculator error or something, there's no way for me to know that. So it's best to show everything that you can so that I can understand everything that you understand. Submit your work for marking. The first method is to scan and send it in electronically. You can scan all of your notes, all of your work through either your iPhone or your Android phone. The iPhone, the Notes app has a scan feature, and Android, the Google Drive app has a scan feature. Then you can send them by email to studentwork@nnec.on.ca and CC it to me, Bronwyn.slate, spelled BRONWYN.SLATE.on.ca, or you can send them through Facebook Messenger to me at bslatewahsa. The second method is to drop it out. We have an outdoor mailbox at 74 Front Street, the side entrance. We're the big red building next to the post office, and there's a small white mailbox that is on the side. Because we're working remotely currently, it might take me a couple days to get them if you drop them off there, but that's fine. I will get them and get them back to you as soon as possible. The third method is to hand it into your DEC. Your DEC can then either send your work through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. If you have any questions, any concerns, any things that you're having a hard time with, please contact me. My email again is bronwyn.slate@nnec.on.ca, and Facebook is bslatewahsa. You can call the office and leave a message for me there. The number is 807-737-1488. It is best right now to leave a message with the front desk, either through the main voicemail or whoever is there. I don't have access to my voicemail while working remotely. You can call us toll free at 1-800-667-3703. And my office hours are Monday through Friday, 8 a.m. to 2 p.m. And I'll try to get back to you as soon as I can. Through social media, connecting with me through Facebook. Here's a visual of my profile so you can find the right me. and my YouTube. Both of them are named B Slate Wahsa. All of our classes are posted on YouTube shortly after they air. And I also have other videos explaining concepts that are either really confusing and lots of students struggle with, or people make frequent errors with. So there are little videos that are maybe 2 minutes or 10 minutes that just focus on one specific aspect. So that's another place where you can go for help if you are struggling with something. Math is a very visual subject. And so being able to connect either through Zoom or through the YouTube lessons is really beneficial. It will set you up for the most success. So please try to access those if you can. All right, today is day 2 of our grade 11 course, and we are continuing on lesson 1 of the IL package, continuing with transformations of quadratic functions. We will finish this lesson today. A reminder of what our learning goals are. At the end of this lesson, I hope that you can say, I will be able to recognize the important parts of a quadratic graph, specifically when it represents a real life situation. And 2, I will understand how A, H, and K change a quadratic graph, which is a parabola. Success criteria, how you can say, I know I've met these learning goals because 1, I can find the A, H, and K values in a quadratic equation. And 2, I can explain the difference between a vertical reflection, a horizontal shift, and a vertical shift. All right, let's activate our brain with a little bit of mental math to get us going to do some more complicated concepts. Many of us experienced math minutes when we were in elementary school, where were very stressful and didn't really help us. So they were just more, if you had it memorized, you were good to go. But if you didn't have your facts memorized, then they didn't help you develop strategies or develop ways to learn your math, your arithmetic. So we are not going to be doing those. I don't believe in those. We're going to be learning strategies as a bonus to figure out how ways that we can do arithmetic and can transfer that knowledge. Today we're going to do a subtraction question. Subtraction is something that many people struggle with and make the same errors over and over again. So having some other strategies other than just the classic algorithm where you stack them and subtract them is really useful. So looking at 24 take away 7, we're going to use an open number line, which is not something I was ever introduced to in elementary school. So an open number line is just a line. You can do it either vertically or horizontally. You can think of it or you can write it down. And then instead of marking all of your points, you're just going to use the numbers that are important to you. So generally, we have 0 or our negative values to the left and our higher values to the right. In English, we read left to right, so that's how we follow it. Same idea. So starting at 24, I want to take away 7. I want to take away friendly numbers because that will make it more accessible to me. So instead of trying to take away 7 completely from 24, I'm going to take it away in chunks that are accessible for me. So I'm going to take away 4 because that gets me to 20. And now I know I've already taken away 4 out of my 7. So I need to take away another 3 in order to take away all of my 7. So I'm going to take away 3, and 3 taking away from 20 is 17. These hops don't need to be exactly perfect. It's just a sketch. It's just sort of visualization of what's going on. So you don't have to be perfect, and you can choose different numbers that make sense to you. So if going from 24 to 20, taking away 4, that makes sense to you, but then subtracting 3 from there, you're not quite sure, and you wanted to do it in 1 jumps and go 19, 18, 17, that would be totally fine too. You do what makes sense to you. So that gets us that 24 take away 7 is 17. Okay, we're going to engage in some prior learning, do a recap of what we looked at yesterday to make sure we can connect it to what we're doing today. We talked about the parent function of quadratic, so y equals x squared. We did a table of values and looked at how we can then graph those and get our graph of what's going on. So we have our inputs that are our x values, the values that we choose, and then we apply x squared to find what our corresponding y values are. Then we looked at the general form of a quadratic, which is y equals a times x minus h, all of that squared plus k. And for our parent function, our a equals 1, our h equals 0, our k equals 0. So inputting them into our general form, we end up with y equals 1 times x minus 0, quantity squared, plus 0, which if we simplify equals y equals x squared. And that's our parent function. And everything, we can modify those values in order to get all of the quadratics. Reminder of k, which we looked at yesterday. So k value is a vertical shift. So it moves our parabola from our parent function either up or down. If we have a positive k value, a value that is greater than 0, our parabola shifts up. And if we have a negative k value, our k is less than 0, our parabola would then shift down. So just a couple questions from yesterday to make sure that we can find that k again. So looking at this, asking to state the parabola shift and what the k value equals. So y equals -2 times x minus 8, quantity squared plus 12. So looking at that, trying to find what is the k value. So our k value, we remember, is that constant that is at the end, often at the end, but it's the constant, it's the part that isn't multiplying by or being affected by x. So k equals positive 12. So that means that it is a shift up 12 units. For 2, y equals 0.5 times x minus 3.7, quantity squared minus 52.8. It's got some decimals in there, gets it a little bit confusing, but we're doing the exact same thing. So our k value is our constant. This time it's negative 52.8. So then because it is a negative value, we're shifting down. It's a reminder of our k. So connecting to new concepts that we're working with today. Those are important to remember, but we're going to be moving forward. We are now going to be looking at H. So this on your IL book is on page 4. Remember, we're not going in the order that the book is. We're going in a little bit more of an order that is conceptually makes sense. So we're going to be examining the H, which in y equals a times x minus h, quantity squared plus k. So we're going to keep our a as 1 and our k as 0 this time. And we're going to change our h to here so that it's x plus 1 all squared. So connecting again, remembering that yesterday we talked about how x can represent the side length of a square and y equals the area. We're going to continue with that example in order to understand this relationship. So when our side length is 0, so our x value is 0, in this case, when our function is y equals x plus 1 all squared, that means that we're adding 1 unit to our side length. And so with that, in this case, because we have this ghost 0 area, because if our side length is 0 plus 0, that original area is still 0. But now when we've added that extra 1 to our side length, we now end up having an area of 1 as well. So when x is 0, y equals 1. Okay, so what that means when x equals 1, now we have our original side length, but we're adding 1 to it. So now we have this new square where our side length is 2. And so then we have 2 squared equals 4. So when x equals 1, y equals 4. When x equals 2, our side length is 2, and we're adding that 1 extra to it. So our side length becomes 3, and our area becomes 9. So when x equals 2, our area, or y, equals 1. Sorry, equals 9. Not sure where the 1 came from. All right, when our side length is 3, and that extra 1, our new side length becomes 4. We square it. So when x equals 3, y equals 16. And when x equals 4, we add that extra 1. So then our new side length is 5 squared is 25. So when x equals 4, y equals 25. If we graph those points, we can see that our graph has moved. Now, each of our points has happened earlier, so we've shifted to the left. Where we need to label our graph, we're looking at this yellow graph as y equals x plus 1 all squared. If we were to graph those points we just did on our table of values, our whole graph has shifted to the left. So now looking at another example, this time we're going to have x minus 1 all squared and look at what happens then. So x equals 0. Well, that doesn't really make sense because with our square example, if we have x minus 1 and our side length is minus 1, that doesn't really make any sense for us because we can't have a side length of 1. So we're not really sure what that means. So we're going to continue the pattern by looking at the other points that make more sense conceptually. So if we have a side length of 1, x equals 1, then we're taking away that 1. And so now we have 0. We don't actually end up having any area because we've taken it away. So when x equals 1, our y equals 0. When x equals 2, and we take away part of our side length, one of our side length, then now we have a new side length of 1, so our area is 1. So when x equals 2, our y equals 1. When x equals 3, and we take away that 1 unit, we end up with a new side length of 2. And so 2 squared is 4. So when x equals 3, y equals 4. X equals 4, and our side length is taking away that 1 unit. Our new side length is 3. So when x equals 4, y equals 9. So if we graph that table of values, we see this new purple line shows our points have been shifted to the right. So looking at more examples, so we can go to this GeoBra app online, and I'll put a link to it in the show notes so that you can go in and explore if you want to. Our A, we are not changing. We're going to leaving our A as 1, and our K, we're leaving as 0, so we're not changing that. So we're just going to be changing our H to continue to see how our parabola shifts. So if I have a positive H value, our parabola shifts in the positive direction, it shifts to the right. If I have a negative H value, then our parabola shifts to the left. The greater the value, the farther it shifts. So we're just shifting along the x-axis. Positive H shifts to the right, negative H shifts to the left. Okay, so H represents a horizontal shift, where a negative H, an H less than 0 shifts to the left, and a positive H, an H greater than 0 shifts to the right. But our general form of a quadratic is y equals a times x minus h squared plus k. So if we look closely, because we think about the examples that we did, we had y equals x plus 1 squared, and that shifted our whole parabola to the left. So even though in our equation, it looks like we have a positive h, actually our h is negative. So this can be really confusing, and it's something to note. So our h in our general form, we're subtracting our h from x in order to modify our parabola. So it's really important to be paying close attention. What happens is that we have y equals x, subtracting is our baseline, and we have a negative h, because when we subtract a negative, it's the same as adding, that ends up looking like h is adding onto x. So our h is negative 1 in this example, even though it looks like x plus 1. So a shift left, your h is negative. It is the opposite of the sign that we see in the equation. Looking at our other option, our other example, y equals x minus 1 all squared, which was a shift to the right. And h here is plus 1. Even though it looks negative in your equation, what's going on is we're saying y equals x minus plus 1 all squared. And so because when you're subtracting a positive, you're just subtracting, we have x minus 1 all squared, or h, if we're doing in general. So that can be really, really tricky. So I just really want you to remember and think about what is happening overall. The h in the equation is the opposite than what you expect. You can think about it kind of like the fact that in our example with our squares, when we added 1, our area got larger faster. So we shifted our parabola over because we were getting faster. And when we were subtracting 1, we shifted our parabola to the left because it was taking longer to increase. But really, you just need to figure out a way that makes sense to you in order to remember that h, the sign is opposite than what you're seeing in your equation. So let's look at some examples in order to practice that point. So we're going to practice stating how the parabola shifts and what the h value equals with an equation. So 1, y equals 4 times x minus 3 quantity squared plus 6. So here we remember that our h value, is what we're talking about, is the part that directly affects your x. This is the part inside the brackets, inside the part that's being squared, affecting your x directly. Here in this example, it's negative. It looks like we're subtracting 3. That means that we have a positive h value, a positive 3. So we are shifting to the right. If we were to put values into a table of values, then we would find that we are shifting to the right. Okay, next example. Y equals negative x plus 25 all squared plus 100. So our h, again, is our value inside the brackets adding to the x. This time it is plus 25. So because it's a positive inside of our brackets, we know that our h value is negative 25. And we're shifting, because it's negative, to the left. Number 3, y equals x minus 17 all squared minus 42. Our h, the value, inside the brackets. It's negative inside the brackets. We're subtracting, so that means that our h value is positive. So h equals positive 17, which means it's a shift to the right. On our last example, y equals -1 times x plus 5 all squared minus 50. H equals our value inside of our brackets. Here it's x plus 5, which means that our h value is -5, and we're shifting to the left. This is something that when I was learning, had a really hard time wrapping my head around why it's like that. And then I ended up just memorizing that h was the opposite sign. So figuring out what works best for you is what you need to do. Okay, so then the next practice question is we want to graph our following functions. So if we're given a function, how can we graph that based off of just the function without doing a table of values? So our example is y equals x minus 2 all squared. So I'm going to sketch it. If you have graph paper, then you can do it more precisely, but I'm going to sketch it. So when I am doing a sketch, I put in my parent function to help me have my baseline, have my place where I'm starting. So y equals x squared is this parabola that goes through the origin, goes through 0, 0. And I know that because my h value is positive 2, because it's in here with the brackets where it says x minus 2, that means my h is positive 2. That's going to be a shift to the right, 2 units. So each of my values, I'm going to shift to the right. So I'm going to go to my vertex, my 0, 0, and go 1, 2. And that's where my parabola is going to be based off of. And then I'm going to sketch it from there, that UV sort of shape. Again, this, if you were doing it, graphing it out on graph paper, you could be more precise in terms of your points, but with just a sketch, get a general idea. So then labeling my graph, y equals x minus 2 all squared. Okay. This example, so y equals x plus 3 all squared. Again, starting with sketching my parent function, to have my baseline where I'm starting, y equals x squared, labeling it, and then saying, okay, looking at my equation, and inside of my brackets, we have x plus 3, so that means that h is going to be -3, which means I'm shifting to the left. So each of my values are shifting to the left, 3. So going to my vertex, I'm going 1, 2, 3. My new vertex will be there at -3, and then I sketch my parabola shape, which is UV. It can be pretty tricky to just get that exactly right, that shape. Going with the curve of your hand can work really well, but I'm having a hard time doing it on the computer. So then labeling that as y equals x plus 3 all squared. And that's how you can graph it with using just the equation. All right, this is a good time if you're watching the replay to pause the video and do some support questions on page 5, questions 2 and 3. We just sort of went through that material, so you can do that now. I don't believe there's anybody with us today, so we won't stop. We will just keep going. Right, now we are looking at the A element of our y equals a times x minus h all squared plus k. So this is on page 2. This is where your IL book starts, and that's where we've arrived. So for our example, we're going to be looking at y equals 2 as our a value, and our times x plus 0 as our h value, all squared plus 0 as our k value. So that just gives us y equals 2x squared. Again, this is where having the visual really helps, because the X is the only element that's squared, not the 2. And that's really hard to see. It's hard to understand when I'm talking and not being able to see exactly what it is that is on the screen or on your question. Okay, so going back to our square examples, conceptually what's going on. If X equals 0, our side length is 0, our area is 0. If we double that, multiply it by 2, our area is still 0. We haven't increased or decreased at all. So X equals 0, Y equals 0. When X equals 1, our side length is 1. The area of our original square is 1. And now we're doubling it. So our area is 2. So when X equals 1, Y equals 2. When X equals 2, our original area is 4. And then we double that. So then our new total is 8. X equals 2, Y equals 8. When X equals 3, our side length is 3. Our original area is 9, but we're doubling that. So when X equals 3, Y equals 18. When X equals 4, our original area was 16. We're doubling that. So when X equals 4, Y equals 32. So graphing those points, we can see on the graph, this orange line is Y equals 2X squared. You can see that it is rapidly increasing. So it is increasing faster. Each of our values are getting higher faster than they were before, to the point that we can't even see our fourth value, our X equals 4 on our graph, because we just didn't have room on my display. So the A value, but we're going to go to our GeoGebra, see what happens if we change our A values. So our H and our K we're leaving as 0, so those ones we'll ignore. And our A, if it is greater than 1, then you can see our parabola is getting narrower and narrower. So it's increasing faster and faster. So if our A value is greater than 1, then our parabola gets more narrow than the parent function. If our A value is between 0 and 1, if it's a fraction or a decimal between 0 and 1, you can see that our parabola gets wider and wider. So to recap that, our A value is called the vertical stretch. And if our A is greater than 1, it's narrower. And if our A is between 0 and 1, it is wider. But that's only half of what A does, because what if A is less than 0? So going back to our GeoGebra example. So if A is less than 0, it's a reflection. It opens down instead of opening up. And it's still, the number still is the same idea in terms of if it's a fraction or decimal between 0 and -1, then it's a wider parabola. And if it's less than, but then -1, then it is narrower. So the number value tells you if it's wider or narrow. Then if it's positive or negative tells you if it is opening up, if it's a positive value, or if it's opening down, a reflection is a negative value. So to recap that, A is also a vertical reflection. A positive A opens up, and a negative A opens down. Okay, so let's look at some questions about identifying the A. So stating if the parabola is going to be opening up or down and what the A value represents. So question 1, Y equals 4 times X minus 3 all squared plus 6. So our A value is our number that we're multiplying before the brackets when we have the full general form. So here it's positive 4. So that means that it is opening up because it's positive. And because it's 4, it's a number greater than 0, then it's narrower. We're not looking too much at the numbers in terms of it being of the number. We're mostly just focusing on if it's opening up or down, but it's good to know generally what's happening. Okay, 2. So A equals the value that is in front of the brackets at the beginning. That's being multiplied by what x is being squared by. So here we have negative and we don't have a number. If we don't have a number, that means that it's 1. Negative, mathematicians are lazy, and if we cannot write something, we won't. So if it's just negative, that means it has an invisible 1, which means that it is opening down because it's negative. And we don't have, there's no change in terms of it being narrower or wider because it's a value of 1. And that's what our parent function is. Okay. In this third example, A equals x minus 17 quantity squared minus 42. Here our A doesn't look like there's anything in front of our brackets, anything multiplying by our x squared term. And that means, again, mathematicians are lazy. It's a +1. If we cannot write it, we won't. So it's opening up because it's positive, and there's no change because it's still a 1 value. Y equals -1 times x plus 5 squared minus 50. A equals -1. So it is negative. It's going to open down. And there's no change because it is just 1. So it's not wider or narrower. Okay, so then we're going to graph some functions to see what that looks like. Again, I'm sketching. So I'm going to put my parent function, y equals x squared first. That's not a great representation, but hopefully you get the idea. My vertex should actually go through my origin. Here, A equals 0.5. Positive 0.5, so it opens up. Because 0.5, it's going to be wider. So we're just sketching at this point, so I'm just going to have a wider UV, and it's opening up as my function. Okay, example 6, y equals -3 x squared. So as we're sketching, we're going to do our parent function, have our baseline, y equals x squared. And then our A value in this one is A equals -3. That's the number it's multiplying. So it opens down because it's negative, and it's narrower because the value is greater than 1. So I know it's going to be opening down and being a narrow UV shape. So y equals -3x squared looks something like that. Okay, so this, if you want to pause the video and do the support questions on page 3, number 1, that's the material we just covered. All right, so let's consolidate all of the learning that we have just done. So we've done transformations of the equations, lesson 1. These are the highlights. This is a recap of all that we did in the last class and this class. So the A value is the opening of the parabola. So in our function, y equals A times x minus h squared plus k. A is the number that is being multiplied at the beginning and is being multiplied to the x squared value. So if A is greater than 0, then the parabola opens up, and if A is less than 0, the parabola opens down. That is our general focus. We don't have to worry about too much about the narrower or wider at this level. H is our horizontal shift. Y equals A times x minus h all squared plus k. So if h value is positive, the parabola shifts right. And if h value is negative or less than 0, the parabola shifts left. This one is the one that you need to remember. The sign is opposite what is in the equation. And k is a vertical shift, where y equals a times x minus h all squared plus k, the constant at the end. So when k is greater than 0, the parabola shifts up, and when k is less than 0, negative, the parabola shifts down. So thinking back to our success criteria, the first was I can find values of a, h, and k in the quadratic equation. So hopefully you can do that now. And the second part was the difference between a vertical reflection, horizontal shift, and a vertical shift as well. Hopefully you can do that now. And if you can't, then we need to go back and look at something again and ask questions and figure out what's confusing. Totally reasonable, but then let's go back and look some more. Okay, so let's put all the pieces together. So we've looked at them all separately, but what happens? We don't look at things generally in isolation. So what happens if we can change all of them? So I'm just going to expand this so that we can see all the parts. All right, our a in our parent function is 1, h is 0, and k is 0. That gives us our parent function. But what if we change those? So if we change our a, we know it's going to get narrower if we increase it. So if we do that, say we're changing it to 3 here, we see how that changes our f function, our orange function. And if we change our h, we're going to say we're going to get a negative h value. I'm going to shift it all the way down to -4, or negative 5. Our h is negative, so we're shifting to the left. In our equation, we see that that is showing up as x plus 5. And then our k value, we're going to move that and move to 2. And so our k value, we're adding 2. And so we have shifted that up. Our positive k value has meant that we have shifted our equation, our function, our parabola up. And you can see how that is represented here in our equation. Okay, another example, we're going to shift. Let's do the opposite. So if we have an a, here a is negative 0.5, so it's negative. So now we're reflected down. We have a negative value is 0.5, so it's between 0 and 1 as our value. So it is a wider parabola. Our h, if we increase that so that we have a positive value of, say, 3, we're shifting our h over to here. And then if we shift our a down to have a negative k value, say -4, see how our parabola has shifted down to 4 because we moved 4 units down because it's a negative k value. And again, our equation has all those pieces showing up. So that's what it looks like when you put the pieces together of all changing all 3. So a couple of quick tricky examples to just pay attention to is that there are other quadratic equation forms. So they don't always show up. The form that we've been looking at is called vertex form. And there's some other forms that are quadratics, but we have to see if the a, h, and k values, we can see those, if they can show up in the same way. So this is the standard form, y equals, for example, y equals 5x squared plus 2x minus 10. And in this example, we have a x squared term and an x term, and then a constant number without a variable. And so in this example, we don't have the a, h, and k in the same way. So we can't just say that a is 5, h is 2, and k is -10. That's not what it means. So in the standard form, we don't have a h and k values. So you can't just pick them out the same way that you can do it in the other form that we were looking at. Factored form is another form of a parabola where we have, for example, y equals 4 times x minus 9 times x plus 7. Again, we can't just say that the first number as we see is a, the second number is h, the third number is k. These numbers mean different things. So we don't, again, in this form, have a h and k values in the same way. So our third form is vertex form. For example, y equals 6 times x plus 3 squared plus 8. And this is the one where we have our a, h, and k. So because we have our x being squared, we just have an x term and it's squared. We have a constant number without a variable. That is how we know that those are our a, h, and k values. So a equals 6, h equals -3, and k equals +8 in this example. So knowing that it's factored form is when it is, we have an x times an x in some way. And in standard form, we have an x squared plus an x term in some way. So that's how you can tell which ones you do have an a, h, and k for, which is important to know and not just assume that whatever you have, it gives the information that you want. So let's do a little bit of practicing of seeing if we can figure out if we have that information or not. So question 1, y equals x minus 2 all squared minus 7. So in this example, we have an x that is being squared and we don't have another x term. So that means that we can see our a, h, and k values. So our a is +1, it's invisible, we don't write it down. Our h is +2, the opposite sign, what's affecting the 8x, and k is -7. What is the constant that is being added at the end or affected at the end? Okay, example 2, y equals x plus 15 times x minus 12. So because we have these two binomials, these two x's multiplying by each other, and we don't have an x squared term, this is not identifiable. We cannot find our a in this form at this point. So our a, h, and k are unidentifiable. Question 3, y equals -5 times x plus 10 all squared minus 6. Again, this is in our form with the x is being squared. We don't have another x term. We only have one x. So we do have our a, h, and k. A equals -5, h equals -10, and k equals -6. Finally, y equals 3x squared minus 16x plus 5. Because we have an x squared term and an x term, that is not in our vertex form. That is unidentifiable. Right? Our a, h, and k we can't figure out just in this form. Okay, so we're going to sketch some functions where we have multiple parts because we just sketched it when we just have one part. So here we have y equals x minus 3 all squared plus 1. So again, it's really important. It's really useful. I don't know if it's important. If you don't need it, you don't have to do it, but putting your parent function can be really helpful to know where you're starting from. So sketching y equals x squared as our parent function, and then finding our parts that we know and how that's going to affect our function. So a equals +1 because there's nothing happening. There's nothing that we see. It's invisible. So it opens up. H equals +3 because it's x minus 3. That means h is +3. So then it shifts right. And k equals +1. It's positive, so that means that it shifts up. Okay, so then how we figure that out when we're sketching or graphing, we're going to say, okay, so we're shifting, we know we're opening up, we're not reflecting. We're shifting to the right 3. So we're going to count 3 units, 1, 2, 3, and then we're shifting up 1. So then we would go up. If you had graph paper, this can be more precise, but again, that's why I'm sketching and not graphing it precisely. And then we can draw our U, V shape, and label our graph. Y equals x minus 3 squared plus 1. And that's what our new graph looks like. If you were to use a table of values or a graphing calculator, that's how you would get that. Okay, let's do one more example of how we would graph. So y equals -3 times x plus 8 all squared minus 9. So starting with our parent function, y equals x squared. Figuring out what our h and k values are. So a equals -3 this time. So that means it's going to open down. It's going to be narrower because it's a value greater than 1. H equals -8. So it's a shift to the left. It's a negative value. And k equals -9. So it's going to be a shift down. All right, so shifting to the left, 8 values. We go 1, 2, 3, 4, 5, 6, 7, 8. My graph isn't great. Something to pay attention to when you're graphing, but that happens. And then we're shifting down 9 values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So our parabola opening down and being narrow is going to be over here. Y equals -3x plus 8 squared minus 9. Sometimes it can be useful to figure out your H and K values before you sketch it, because then you know how far you're going to be shifting, but it's also not a big deal to be having a slightly squished sketch. Okay, and that's how we figure out how we can sketch our graph from our general form function. All right, so practice application question number 7. We're going to do some word problems. A basketball was thrown upward. The basketball's path was given by the relation y equals -0.2 times x minus 2.5 quantity squared plus 4.25, where y is the basketball's height above the ground and x is the basketball's horizontal distance from where it was thrown, both of these measured in meters. So what was the basketball's greatest height above the ground? For me, when doing these sorts of word problems, drawing a sketch is really, really helpful for me to visualize what's going on. So we're going to start by doing that. So again, this is a sketch, it doesn't have to be perfect. Knowing what my A, H, and K are going to help me sketch this. So A is -0.2. So that means that it opens down. And it's wide. H is plus 2.5. It's x minus my H. So that means that it's shifting right. 0.5 units. And K is plus 4.25. So that's shifting up because it's positive. All right, so a shifting right, 2.5. So 1, 2.5, and then shifting up 4.25. 1, 2, 3, 4.25. So my vertex is going to be there. And then I'm opening down at a wider angle. So my parabola is going to look something like that. Not amazingly drawn parabola, but we get the idea. Okay, so the question is asking us what was the basketball's greatest height above the ground. So we can see from our diagram, as poorly drawn as it is, the general trajectory of the ball is to go up to the tallest point and then down. And we found this tallest point because that was how much we shifted up, right? So 4.25 is our highest point. So to answer A, basketballs it's not the word. The basketballs greatest height was 4.25 meters. We write it in the sentence so that we know what we're talking about. Just saying 4.25 doesn't tell me that you know what it is that you're talking about. So it gives a context. The point of doing word problems is to give context to the random numbers that we were working with before, because we live in a world with context, not just with random numbers. Okay, part B. What was the basketball's horizontal distance when it was its greatest height above the ground? So how far did the person throw it for it to, when it hit its greatest height? Basically is what that's asking. So its greatest height is here. We know that happened when we shifted over 2.5. So the horizontal distance was 2.5 meters at the basketball's greatest height. So having that diagram and breaking out the information that we know was really helpful for us to interpret these questions. All right, question number 8. The curve of a cable on a suspension bridge can be modeled by the relation H equals 0.0025 times D minus 100 quantity squared plus 25, where H is the cable's height above the ground and D is the horizontal distance from the tower, both in meters. So again, that's a lot of information. Figuring out what it is that we're talking about is really useful. And so there's an image. Sometimes textbooks or questions give you an image and then we have to interpret them. So let's figure out, we have a suspension bridge. So thinking about like the bridge in Nipigon has these long tall towers and these long braces. And then figuring out what our A, H, and K are from our equation to figure out what we can figure out with those things. So it's important for this question, even though our parabola kind of looks like it extends, it has multiple dips. We're just looking at this section where in relation to this, to one tower is what this says. The distance, the horizontal distance from the tower compared to the height above the ground is what we're looking for. So we need the tower and the ground that's what our axes are. Which is a good point that this, I've drawn my axes as the bottom of the bridge, but we're comparing it to the bottom of, to the ground. So really my axis should be down here where the ground is. Okay, so A is positive 0.0025. So we have a very wide parabola that is opening up. Then our H is going to be plus 100 because in our equation it says D minus. So that means that our H is positive and our K is plus 25. Okay, so what is our question even asking? That we're just interpreting the information that we have. Oh, so our H, sorry, we should interpret that as well. I mean, tell us what it means. So our H being plus 100 means that we are shifting the right, which makes sense, right? We've shifted to the right. And our plus 25 means that we've shifted up, which also makes sense that we've moved. So our parabola has shifted over and up compared to our axis. Okay, so A, what height does the cable meet the tower? So where does our cable meet the tower? That happens right here. So right here is where our cable meets the tower. So that is happening when what is happening? Is that any of our information that we usually have been interpreting? They're talking about our opening? No, it's talking about our distance that we've moved it, either up or to the right. No, it's talking about what happens when when our distance from the tower is equal to 0. So when our distance to the tower is 0, we haven't moved anywhere from the tower. How high are we? So we can input 0 into our equation to figure out what our height is. So we replace D with 0. We can solve this either by doing your order operations or by using calculator. So 0.0025 times negative, so 0 take away 100 is negative 100, squared is going to be 10,000 plus 25. 0.0025 times 10,000 is going to be 25 plus 25 equals 50. So the cable meets the tower when it is 50 meters in the air at a height of 50 meters. I don't have enough room to write out a complete sentence, but I should. Okay, B, what is the least height of the cable above the ground? So what is the lowest height that's happening here, right? That's the lowest height of the cable is. So our lowest height is our vertical shift. So it's 25 meters is our lowest height. And how far from the tower is that lowest height? So that lowest height happens at this distance from the tower. So that lowest height happens at 100 meters from the tower, because that's how far we shifted over. So as you can see, just having the numbers doesn't really tell us what we're talking about. That's why writing sentences is really important and leaving yourself enough space to do so. All right, thank you so much for joining us. If you have any questions or concerns, please contact me. That is what I'm here for. You can give me a call and leave a message at the front desk of the office at 807-737-1488 or toll free 1-800-667-3703. Or you can email me at bronwyn.slate@nnec.on.ca or Facebook me at bslatewasa. I will be posting this video up on YouTube, so check it out if you need to view it, and so it can help you out with your work. I hope you have a great day, and miigwech.